My name is Seth Berman. I'm the CEO of Instantiations. And so this one, I did a talk this morning about kind of company update types of things. This one's going to be much lighter weight and probably a little bit shorter. I guess I put all my energies in the first presentation. But this is some really cool stuff that we've got going on with the compression streams from an architectural standpoint. And we've got some really nice new algorithms for some upcoming some upcoming things that are happening. So this is the Unified Compression Streams, which is a new framework that came in last year, which provides basically streaming support, composable streaming support over codec-based, basically codecs, compression, decompression type of things. So just I'm just going to run through some design goals. Talk about the compression support that we have in the product, and then I'll kind of cut out of this and just do a little walkthrough of what it looks like in the product. So as far as some design goals, so the first thing is we wanted it to be really high performant. That's usually a goal. It's a good goal to have. And usually in this context, that means really good buffering, really good decisions about buffering, and so another goal we had was a unified API, but not just so that is the same API for streaming for all the compression algorithms, as well as if we're wrapping it over a in-memory stream, a file stream, or a socket. And so in VA, historically, the streams have been a little bit disjoint in terms of the read stream, and then we have a CFS file stream, and then we have a separate kind of socket stream, SSD socket stream. And so one of the goals was to also kind of, if this thing is going to wrap around all three of these, that it does really good adaptation. And as part of the work, we were able to kind of unify those separately, but that's really a different from this effort. So as I said, composable. It should wrap around other streams, and easily extensible. So extendable. So I will show what it looks like where we basically enabled our LZ4 codec for streaming, and it's just a handful of methods, which will probably make sense once you see them. And then you get, really nice performing streams, for free after that with a really rich API. And it does some things that you won't see most compression-based schemes do, like peak, because it can be tricky when you're pulling. If let's say you're at the end of a buffer and you do a peak, and now you just don't grab the next thing. It could be a whole chunk of data that you're going to grab just to get the next logical item. So we have some pretty cool stuff for to make a real nice, rich API for streaming. So here's what we have in the product at the moment. So we have DEFLATE, GZip, which is kind of like DEFLATE but with a header. We have LZ4, which got introduced last year. ZStandard is a kind of a modern compression scheme from Facebook that we had as that we kind of just released as for the community last year, but we've actually rolled it into the product this year, so it comes standard. And we also have Brotli now, so Brotli read-write streams, which is kind of taking off on the web. It's good for web compression based things. And finally, I mean, anybody who's done Java or C# will know how this works, but we have a zip stream that's essentially, and I'll talk about, and we'll show how it kind of works, and it's essentially a double cursored stream. Because a zip archive is just a bunch of entries, essentially followed by a kind of directory at the end. But really, you can just look at the entries and cursor over those. And then, so you kind of position for cursoring over entries with a special API, and then after that, it's the same API. You're now just using next put and that kind of stuff. For all the compression support that we provide, we also separately provide the one-shot support, and that's for performance. So, for example, so something like a byte array, where you have a gigabyte byte array that you want to LZ4 compress, you don't need to stream that. You basically know the size. You know everything that you need to know. It's all there. So you can actually do some separate optimizations to take advantage of the fact that you have all your data. But sometimes you don't. So like streaming over a socket, for example, you don't actually have all your data. So that's where streams come in really handy. So there's an example that's essentially an equivalent example at the bottom for the streaming version for right now bytes. Okay, so I'll kind of get out of here and I'll just kind of move over to the product real quick. So as far as tests, I mean, this is kind of interesting. I know there was a lot of presentations on testing, and I think that's really great because tests are really important. And so we use for testing all this stuff, we have SUnit test suites, which are really pretty exhaustive because we did do all these APIs, and sometimes there's really specific things that happen. For example, peak here. Peak is really hard sometimes for these streaming deals. In fact, there's one edge case where you're at the end of your buffer, your uncompressed buffer, and you need to peak because you're at the end now. And so now that there's a whole lot involved in actually getting the next thing, and you just want to see it. You don't actually want to necessarily have it. So so there's a bunch of tests here just to make sure that every existing API works if you're in that edge case. And so, we have that, and so they're all up at this kind of abstract level. So then if I do something like, we'll just test. So, everybody will have, so hopefully this will all, hopefully these will all pass, but it's essentially everybody's kind of running the same test. Now the zip streams have some additional tests to account for, how it works just slightly differently. It's got a slightly extended API so that's why if we go here, for example, you'll see, so here's a new feature that came in 9.2, which was to be able to store file names in the zip with UTF-8 encoding. And so, we got a test like that, or, something related. Okay, so just to show you, I mean, really these examples, and many of them are going to be similar, will just show you essentially how to do the one-shot version and how to do the streaming version of essentially the equivalent thing. So for deflate and GZip, I mean, you take some bytes. It could be string or byte array, and then you deflate it, and hopefully if you inflate it, you'll get the same thing back. And then for so most of the things follow this pattern. So GZip compress will basically, now this will probably end up being larger than hello string, I would suspect, because of the header information. But typically you'd have something much larger. But and then it's GZip decompress, and should get back the same thing. Now for streaming, we have deflate RightStream, and it's all going to kind of work the same. Next put all hello world. So that's exactly the same situation. Then we have inflate ReadStream, and then GZip RightStream, GZip ReadStream will all do the same kind of things. So then the nice thing, and I'll show the API, in the class browser in a moment. But here's the LZ4 version. So it's LZ4 compress, and then LZ4 decompress. And this is a really quick, in fact, we can do let's do a little trial here and see what happens. Let's try 1, 2, 3, 4, 5, 6. Let's try a gigabyte, see what that does. Hopefully something good. Okay, there's a gigabyte. Now, oftentimes I also use like OSS, random generator to get your worst case, but this may be just end up being really fast, but so in this case, it's all the information is there, so it's really quick to get your to basically go over a gigabyte byte array and LZ4 compress it, and then LZ4 decompress. We'll see how long that takes. These algorithms do have different times for these. Detectably a little bit longer, but not much. So that's a really quick. You don't quite get the same compression level by default that you would with some of the others, but for the most cases, it's good enough and really fast. So this was that new one that's from Facebook. It's got really fast. I can't remember if it's the compression or the decompression that's really quick, but it's favored in a lot of different areas, and so it's the same thing. It's really the prefixes here are changing. So in this case, it's ZSTD compress, followed by ZSTD decompress, and hopefully you will get the same thing, and followed by the streaming versions. And then this is also going to be a 9.2, which is the Brotli compression. So that's Brotli compress and Brotli decompress. We'll give you are the APIs involved, and followed by those are the streaming versions there. And so this is kind of the interesting one for folks who maybe haven't seen this pattern before. But like I said, if you've used Java at all and you've used these zip streams there or C#, you'll pretty much understand right away what it's going to do. So basically, let's create a zip archive. So I'll put it on my desktop here. In fact, let me take this into a workspace so I can cache these. I'll make this. Okay, and then I'll inspect it just so you can get a sense of state. Okay, so it's keeping track of a lot of stuff. And so we have, so now this is now a file stream that's opened on the desktop here. And you can see we can set a comment and then just next put entries. So this is the entry cursors. So we're gonna put a new entry named file1 into it. And then and so now the cursor is positioned at file1.txt, that entry. And then we're gonna use normal stream APIs to do whatever we want to do to that entry. So next put all, I am the contents of file1. And then we can move to the next one. And then you'll do the same thing. And so you just keep doing that. And then it's the same thing for read. So let's go ahead and write this out. And then I'll just inspect it real quick with 7-zip just to show you what got written out. So let's go ahead and open this archive. Okay, so there's file1.txt, which hopefully has I am the contents of file1, so pretty straightforward, I think. And then there's the directory with file A and file B, and those are the same thing that you saw. And you can see, I mean, there's a little code to write a zip archive real quick. And then as far as the properties go, we see that comment has been put in the appropriate place in the metadata so that you have as part of your zip file. And then reading it is, on the way back out, has a similar feel. So now I'll go ahead and open the ReadStream on this. And so we can, and there's actually several additional APIs that you don't normally see. These were actually extended kind of APIs I thought might be useful in certain situations. So and a little bit more Smalltalk like than maybe a Java or C# counterpart. So we have entries collect. So even if you were on the last entry, entries collect will start from the beginning and do everything, and then position back to where you were. So it doesn't really ruin your current location in the zip file. But we can do something like self entries collect each, such that each name. Let's see what if this. Let's see here. All right, so and that's just going to cursor through each one and each entry and just get the name. And then we should be back where we started. So if I do this again, it should actually still be okay. And then let me update here. And my entry is still nil. My active entry is still nil. So it's back where it started. You're at the beginning. And so we have entries do, entries detect, entries select. So this is the entry cursoring. So that's how and so the zip ones are really nice. And as I said, we now have the UTF-8 naming as well that you can put in there because that's some extended metadata. And I'll go ahead and show you just some of this, some of the API and kind of architecture. So a zip ReadStream, and this is kind of from the C# and Java world. It was a subclass of inflate ReadStream, which you could make a good argument for. That doesn't make complete sense, but it's probably more of the inheriting of the fact that the normal API of the stream really does act like the inflate read stream, and that the cursoring is something a little extra. But as far as is kind of, you could make an argument that that's not the best choice because you can actually have zips full of contents that are not compressed at all. And so it actually select if it really should do that. The zip streams also support zip64, which is another nice feature about them. But these are all a kind of so if we look at in compression read stream, this is the API. And so it's pretty nice because we get the API you would expect, but then we get things like peak, which can be complex. And you can kind of get a sense from the source code that you might be looking at that the way that peak is done is by prefetching buffers and kind of accounting for that all along the way. Again, it's an edge case, and it's unfortunate to have to deal with, but it does lead to having this nice full API. You can do positioning as well, and it's a virtual position. So that if you know your place, your position in a compressed file, you can actually get there, the virtual position, the actual position, as if it were uncompressed. You can put it there. Now these are less used features. They would only really be used in specific cases. Most of the time, you just stick to your normal ones. But in VA, like something like next, or next, an integer or something would. If it ran out of space, you get an error. You get an exception. Exception is raised if less than integer elements are even available. And so that's actually a VA-ism. Somebody may know if that's actually an ANSI thing or something. I don't know off the top of my head, but I know in VA the next behaves that way, and that's not always desirable. So we have a bunch of try versions of those, where you get, if you have no more elements, you get something more like nil. You don't actually raise an exception, because there's a number of cases where the exception thing is kind of unfavorable. And then we got skips and up-tos and all these kinds of things. So yeah, this is the ReadStream version, and we use it for a lot of things. Like you can see here, part of reading ping files uses special versions. Part of actually even the new IMAP support, because IMAP supports compression. And so we can transparently make that happen by wrapping one of these compression streams around the socket, what the socket's handing back. And so it's really nice to reusable and reusable. But as far as you might say, well, what does it take to actually, let's say I have a codec, and what does it take to actually make it streamable in this way where you get pure high performance streams? Because these things are, they have an uncompressed buffer and a compressed buffer, and they can be configured for maximum performance for whatever your situation is, and you kind of get it for free whenever you latch on to the read stream. So let's take a look at LZ4 read stream. And this says, what things this subclass responsibility says, what things you need to actually, either, this is the extension point, so it's kind of an optional but recommended version. But you can see here, I mean, basically it's close, and then, I've got a chunk, I got a buffer of some size and a source of some size, and, run your algorithm over it. I mean, that's the big one. And of course, that's all handled for you where the boundaries of that are. But sometimes depending on the codec, reset may be needed. You can see here that there's some optimizations based on what we know about the LZ4 algorithm, that we can pre-size these buffers in more of an optimal way. And so we have initialized buffers for the various algorithms based on just what works best as a default for those algorithms. And then we even have these are more specialized, like because we do skip to and up to, and you may want to enforce buffer size, default buffer sizes a little bit differently. But that one has so here's ZStandard. It's really just the close and the update and the reset with the I got a better understanding of what a default buffer size might be. And then Brotli had some there was some different, every codec, especially if you're binding onto a C library, has different idiosyncrasies to it that mean you have to sometimes do things a little bit differently. But usually I found it pretty easy to hook into where I needed to get to. Okay. Let's see if we go back. And let's see, we've been over so the read, we've been over that, and the write. So yeah, we've pretty much covered. I said it was going to be a little bit shorter, but I think that folks will really appreciate the ZStandard and Brotli. We're going to do more work in the next round for our SST HTTP client, where we'll have it auto resolve pages that it's getting back from the web, and Brotli is being used more as an option, so it's going to automatically be able to do those. Where right now it's a little bit more manual. But for the most part, folks have been pleased with it, and it's pretty easy to hook up your codec to these guys. I guess the one thing that I'll show that I am just remembering now that I need to do is the RightStream version. So RightStream has just a handful of methods that you need to do, and it's pretty easy to hook it up. So let's go to Brotli, for example. Same kind of thing, flushing in this case, and some sort of compression update this time. And so, yeah, pretty easy to turn your codec into streaming stuff. So that's the end of the presentation. If there's any questions, I'd be happy to take them.
I noticed in that ReadStream example, zip ReadStream example, that you open zip ReadStream on an instance of CFS file ReadStream. Is that correct?
Yes. Let me get back to.
So I'm interested in how, if you have any API that is more generalized to wrap streams in streams, or is this just that one specific example where you do that?
Yeah, so as I was saying, the CFS read stream, the SST socket streams, and the canonical read stream, write stream have not had that composability feature, and so this definitely does, and we'd like to get that into the those that I mentioned. But yeah, they've been disjoint, and that needs to be corrected. But yes, here we made sure that it could wrap whatever. It's a good question.
I have two questions. First one, why do you divide in next put entry and next put all? Is there something like next put file? And my second question is, do you have class comments on your new classes?
Can you repeat the last question?
Class comments for the new classes.
Should. That's part of our coding standard, so if I missed it, shame on me. But let's see if we got Oh, there you go. Yeah. We do have, so our new coding standards at Instantiations for the last couple of years has been class comments for everything and method comments that look roughly like that. So args and answers and things. So yeah, you'll notice a lot of code in VA that's, we call it, and internally we call it the 1996 code. That's pretty much just slapped in there, and you know, it's anybody's guess in some cases what the person was actually trying to do. But you know, one of the issues, I mean, even formatting can correct a lot of these cognitive issues. But the problem we found is that if we just bulk format everything, then some of our customers get really upset with us because they see it as a bunch of diffs that, you know, now they have to account for in their migration. And so that, you know, so now we kind of do it as we go along. Now your first question, why the, this is a good question, by the way, and I failed to approach this, but so the next put entry, so you can have an in-memory zip stream. So it's not really a file, it's just an entry. So you can actually take a zip RightStream and wrap it over just a string new, you know, ReadStream, and actually build a full archive in memory. Or you can stream it over a socket incrementally instead of needing to build the whole thing at once on the file system and then only afterwards ship it off. So you can actually, and so it's called entry from, and it may be the spec, I can't remember, but because it is more of a general entry rather than a file.
Thank you very much. This is very nice.
Thanks. Any others? Okay, thank you.